record. Hello, everyone. We are now in week 13. We are coming to a semester's coming to a close, guys. It's only a few weeks away. It's very sad. But while we're here, we still have more math to do. So let's move on to chapter 17, more on correlation and regression. So we've been working on correlation and regression. I'm emotional too, Angela. I'm emotional too. More on correlation and regression. Okay, so we've been working on correlation and regression now for a few chapters. We had one chapter on correlation, and then we had a follow-up chapter on regression, and now we're more on correlation and regression. Okay. And we're going to come up, or not come up, because that would imply that we're going to derive it. But we are going to have in this formula two formulas. One formula is going to be for the best fit line, which we have given, but haven't actually given a formula for yet. We're going to come up with one today, or at least have one today. And we're also going to have a formula for the correlation coefficient, also of which up until this point has only been given. Okay. So we're starting with towards a formula for correlation. We're not going to derive the formula for correlation, but we are going to have a deeper understanding of it. So this scatter plot shows the scores of 37 students on the first and second tests of the semester. The axes have been located at the mean score for test 1 and the mean score for test 2. So normally, when we set up our axes, we normally have the x-axis and the y-axis meet at 0, 0. We didn't do that. Laurie, you're here. You can't just come in late.
Sorry. No, I'm sorry. My computer's like running super slow.
Super slow.
I don't know why.
Laurie, I was like worried about you.
Oh, you're so sweet.
Oh,
Thank
so
you.
You're always here, so I was like, where is she?
I know. Thanks.
It's
just
really
my
worried.
computer.
All right.
I think I'm on dial-up right now.
Wow, I remember that.
Yeah, you can't make her absent. You have to mark her here.
I have to make a grand entrance. Okay, sorry. Anyways.
And that you have. So let's go back to attendance. I'm not going to go forward until I mark you as absent. Other words, I'm just going to forget. Laurie. Okay, you are now absent. You're now here. Okay, so we have the scatter plot, and we have the x-axis and we have the y-axis, and the center is at the average of the x's and the average of the y's. They've calculated it for us. They've told us that the x average, the test 1 average is 73.6. So 60, 80, 73.6. And the average for test 2 is 70.05. Here's the y at 70.05. Now, is the association linear? In other words, do the points kind of form an elliptical cloud? Is there like, remember, linear does not mean a straight line in statistics. It's near it. Is there like a cloud of points that most of them fall in? And
yes,
the answer is yes. I even already drew it. So the answer is yes, there is. What is the direction of the association? Is it positive or is it negative?
Positive.
Positive.
Positive. Now, let's go one step deeper. If you look at all of these scores here, you'll notice that they're above average in the x direction and also above average in the y direction. And if you look at all of these scores here, you'll notice that they're below average in the x direction and they're below average in the y direction, correct? These ones and these ones have one above and one below. Do you agree?
Yes.
Are the majority in the first case or the majority in the second case?
Is the first case the one in the bottom?
The first case is either both positive or both negative, both above average and both below average, or one above and one below. These guys here and these guys here are all either both above or both below. These ones here are x above, y below, or x below, y above. You can see the vast majority of them either fall above and above or below and below. Do you agree?
Yes.
Mhm.
Okay, now this is important. This is, you're like, well, that's kind of obvious, but yes, but it's very important to what's coming. If the association is positive, then points with X values that are above average tend to have Y values that are above average. If the association is positive, then we're going to have lots of them here and here. We're going to have lots of points where if the X is above average and the Y is above average, and points with X values that are below average tend to have Y values that are, anyone?
Above average?
Try again. If the
Say
association
the
Above
question again.
average?
below average. If the association is positive, then we expect above average X values to have above average Y values and below average X values to have below average Y values,
That below.
right? Either they're both above or they're both below. That's what we expect. That's the majority of them by far. Okay? Let's look at these two examples here. Which of these two examples would you say is the stronger correlated? The one on the left or the one on the right?
The one on the right?
The one on the right, correct? Let's go ahead and try to guesstimate the averages in the X direction and the averages in the Y direction. Where would you say roughly is the average in the X direction here? Would, I don't know, somewhere in the middle make sense, give or take? And maybe a little below average for Y. Does that seem like it's a reasonable average X, average Y?
Yes.
Maybe this one should be moved a little.
Are you looking because it's in the middle or just trying to divide them all up evenly? I
Well,
don't know.
yeah, trying to have the center of the axes be like an average in the X direction and an average in the Y direction.
Right.
So in the second case, so let's see if we can fix this maybe. I don't know if I like this spot here. How do I grab this? Maybe something like that. And then let's do this one here. This one looks to be more like, I don't know, let's say, oops, let's say it's something like that, and I don't like that. Okay. Even if these aren't perfectly correct, they're certainly what I'm trying to illustrate. So, okay. Sorry, 1 second. Okay. This is certainly what I'm trying to illustrate. Does that make sense so far? What we have here? Any questions? Yes, no, maybe so. Anyone?
Trying to connect the dots.
Well, the goal is as follows. What we want to have is we know that in the second case, at least, is it positive correlation or negative correlation? Which would you think in the second case?
Positive.
Positive correlation, correct? Okay. So we expect to have lots of them in the upper left, the upper right and the lower left. Do we have that?
Yeah.
Okay. So that makes sense, right?
Mm-hmm.
In this case, it's not as correlated. So when I look at the upper right and the bottom left, I have a lot, but I still have lots of stragglers in the other two. The more strongly correlated it is, the more you're going to have it in the top right, bottom left. Okay, and the weaker correlated, the more spread out it's going to be, and when you have some in the top left and some in the bottom right as well. And we're going to see exactly how that manifests itself mathematically as we go further. So, true or false? the stronger the positive association, the stronger the tendencies for the XY pairs to either have both above average or both below average. Would you agree with that?
True.
True.
Saying positive because it's above, either below average.
I read that question, make sure you understand it.
The stronger the positive association, the stronger the tendency for the XY pairs have either both above average or both below average.
Read it, make sure you understand it.
Well, I'm stuck on the both, maybe because I got there 5 minutes late.
No,
Either
we
both
didn't really
above-
start. We didn't really start till you were here. We didn't really start till you were here. So
Well, that's
excuse
that's my
ain't-
story, and I'm sticking to it.
that excuse ain't working here today.
Either both above average or both below. I get the above average meaning positive, but I don't know what that has to do with below average. Is that
If they're
because you have
both-
to get the idea of the direction it's going?
Yeah, if they're both above average, then that means they're both going to be in the top right. If they're both below average, then they're both going to be in the bottom left. If it's very strongly correlated, that's exactly what we expect. You don't like that?
I don't know. Maybe it'll come later.
No, it has to come now. It has to come now.
Well,
Things
well,
don't
what
come
is-
later. People always say
How-
it'll come
how
later,
did
but
I
it never
mi-
comes later. Huh?
How did I miss correlation? What does correlation have to do with anything?
Oh,
You know what's bothering me right now is I'm trying to print this thing so I can fill in the notes, but I'm having
Okay.
trouble getting it. So I might have to sign out and sign back in. So
Uh,
I'm going to leave for a minute and come
okay.
back in.
You know
Sorry.
what? We'll wait for you. We'll wait for you. We're not really gonna wait for her. No, I'm just kidding. We'll give her a minute. How's everyone? I'm gonna pause sharing for a second while we wait, so that if you're watching this later, you resume recording and resume sharing. And okay, so what we have here is the following situation. Okay, if it's very strongly correlated, like this one is compared to this one, then most of the data points are going to be here and here. Do we agree with that? That means most of
Yes.
the data points are either both above average or both below average. So true. The stronger the positive association, the stronger the tendency for the XY pairs to have either X and Y both above average or both below average. If the association is negative, then we expect it to go this way instead, correct?
Yes.
And in that case, we expect lots of them down here in the bottom right and lots of them up here in the top left.
Okay.
Correct?
Yeah.
If the association is negative, then then points with X values that are above average to the right will tend to have Y values that are below average underneath. And points with X values that are below average, X values here on the left, are going to have Y values that are above average.
Of average.
Okay. And here is the actual formula for the correlation. Okay. And we are now going to see how this ties in with what we just covered.
Can I ask you a quick question? What's the lecture number of this so I can go back and get the beginning part again?
Well, it's the 13th week, and that would be number 25 if we have not skipped a day. We missed a day? Did we miss a day for any reason?
Yes,
No.
last week.
Because you had like a test or something, I think.
Oh, no, we actually had missed 2 days then. But
Yeah, we've missed two.
so this might be the 23rd lecture then. This might be the
Okay.
23rd lecture. Okay. Anyway,
All right. Sorry about that. No more distractions.
okay. So here's the formula for correlation. Now it's a complicated looking formula, but as you know, one thing about math is that things that look complicated are not always as complicated as you think they are. Okay. So what we're going to do here is break it down. First, what is X bar?
Average.
The average of the what?
X's.
The average of
Average
the
of
X.
the X's.
And what is Y bar?
Average of the Y's.
Okay, we know what those are. What is S sub X?
That's a good
Deviation?
question.
Thank you. I thought of it myself. Yesenia, you had an answer there?
The standard deviation.
The standard deviation of the X values. And what is S sub y?
Standard deviation of the y values.
Okay. What is N?
The number of pairs of x and y pairs.
Okay. And,
What does that mean? Number of pairs?
oh, a number of data points. Number of dots on my scatter plot.
Okay.
Okay. And what does this mean?
The sum.
The sum. In other words, what we're going to do is we're going to take this value times this value and do that for each point and then add them all together. So we're going to calculate this. We're going to calculate this. We're going to multiply them. We're going to add them all together. And then we are going to multiply by 1 over n minus 1. When we do that, that will give us R. That will give us the correlation coefficient. Now, I'm not deriving this formula. I'm not explaining where this formula comes from. We're just accepting as fact that this formula is valid, okay, without worrying about where it comes from at all, okay? Okay, now, these things, x minus x bar over s sub x and y minus y bar over s sub y, we've actually seen those before. What do we call those guys? Or girls, you never know what they are. But what do we call them?
Can you
Hold,
repeat? I'm sorry.
please.
I was thinking of something else. Sorry. Can you repeat it?
X minus
Is
x
it like
bar,
the mean?
no, x bar is the mean. X minus x bar over s sub x and y minus y bar over s sub y, those things have a name. What are they called?
T-scores or Z-scores?
Yes.
I don't know.
Yes, that's what
What?
they're called. That's exactly what
Ding,
they
ding, ding,
are.
ding.
Boom. Z-scores. Awesome. So essentially what we're doing is we're calculating Z-scores, multiplying them together, adding them, and then multiplying by 1 over n minus 1. Okay?
Why would we want to do that? No, just
Because
kidding.
this is a formula that somebody a lot smarter than me and you came up with. All right, so we just accept it. Now, if x is above average, then this quantity is going to be what? Positive or negative?
Positive.
Positive, because x is bigger than x bar. So if x is above average, then this quantity here is positive. If x is below average, then this quantity here is going to be
Below average. Or
well,
negative, rather.
negative. And if y is above average, then this quantity here is going to be what?
Positive.
Positive. And if y is below average, then this quantity here is going to be what?
Positive?
If y is below
Negative.
average,
Oh, negative.
then y minus y bar is a negative number. And we expect a negative here, correct?
Yes.
Yes? No, no, so? Now,
Correct.
when x and y are above average, when they're both above average, then when I multiply them, what's it going to be?
Positive.
It's going to be positive. And
Because a positive times a positive is positive.
exactly. And if they're both below average, then what's it going to be then?
Well, I would think it's positive.
It would be positive. If they're both below average, they're both negative, and two
Negative
negatives
times
are
a
positive,
negative.
right? So if we have a linear associate, so everything in one, all the dots in one, when I multiply these, will they be positives or negatives?
Positive.
Positives. And all the dots in two, positives or negatives?
Into the quadrant 2,
Yeah, in quadrant 2, positives or negatives?
positive times positive is positive.
Right. But if we're here to the left and x is below average and y is above average,
Oh,
and that will be
negative.
less than 0. Here, they're both below average. So what would it be?
Negative.
No, if they're both below average.
Below, oh my gosh, it's so hard to make the correlation between the graph and these
I
little
know. That's
formulas.
why math is hard, because we have
Yes.
to connect all these different things at the same time. And
Okay,
how
so negative,
and
the
those will be
positive.
negative. Those will be negative, right?
Yeah.
So if I have a positive association, then I expect lots of positive numbers and not very many negative numbers. So that's why if I add them all up together, do I expect it to be positive or negative?
if you add all them together,
Again, if I have positive association, so most of the dots are here in 1 and 3,
oh,
so that when I multiply these, I'll get lots of positives.
you'll have positive.
It'll
'cause
probably be positive, right?
Yeah.
If I add up lots of positives and a few negatives, it excuse me, it's probably going to be positive, right?
most,
Which is why a positive R corresponds to something that looks like this. If it looks like this instead, then now I expect most of the dots to be in here and here.
mhm.
So I'll have lots of negative numbers. And when I add up lots of negative numbers, I expect R to be negative, which is why a graph that looks like this would have negative correlation. So this is the explanation for why R is positive for graphs that go up and R is negative for graphs that go down. Lori, you had a question?
What is the standard deviation in situations like this? Is it how many
Well,
points below a line or something?
no,
Or
the standard deviation is computed for X and Y separately.
but we don't need to know that.
No, you don't have to worry about that. They're computed for X and Y separately.
Oh,
Okay, so you don't need to worry about that.
all right.
So for a positive association, most of these terms will be positive, so R should be positive. So I kind of already filled it in. For a positive association, most of the terms will be positive, so R should be positive. And in fact, R will be positive in that case, which is how R works. Okay. When X is above average and Y is below average, then we're in quadrant 4. The product is gonna be
Negativity.
negative. When X is below average and Y is above average in quadrant 2, the product will be negative. For
Negative.
negative association, most of the terms will be negative. So R should be negative.
Negative.
And if the association is very weak, then there should be about the same number of terms, positive and negative. So for a weak association, R will be close to
Negative.
no, why negative?
Because it's a positive and a negative.
No. It's not each individually. When I multiply them, some of them will be positives, some of them will be negatives. And when I add them all together, it should be close to what value?
Oh, positive. You're still talking about
No, it's still not positive. No.
close to 0?
Close to 0. Close to 0. If I have lots of positives, if I have lots of dots here and here and here and here, those will be positive. Remember we said this, right? These will be positives. These will be negatives, positives, negatives. And when you add them all together, lots of cancellation, and it should be close to 0. If it's positive association, lots of positives and very few negatives, it should be positive. If it's negative association, lots of negatives and very few positives, it should be negative.
Negative.
Weak association, they're all over the place, lots of positives, lots of negatives, and you should get something close to 0. Does that make sense?
Yes.
Okay. I hope so. No one's asking anything.
Even
Hopefully you'll have
rocket science.
We're getting there. So, interpretation of R squared. Okay. R is the correlation. Okay. And the correlation is important. There's no question about it. The correlation is important. However, there's no physical interpretation of R. R squared, on the other hand, does have a physical interpretation. And this interpretation is what we're working on now. Okay. So the closer R is to 1 and -1, the closer R is to 1 and -1, the stronger the linear association, correct? We've talked about this before. Do you agree? Everyone?
Stronger the linear association between the
The stronger the linear
closer.
association, the more on a line they are, the closer R is to being exactly 1 or -1. +1 if it's up, -1 if it's down. Correct? You guys
Okay,
with me?
yeah.
Okay.
Yeah.
Now, if R is not 1 or -1, then let's say I get R is 0.32. What does that mean? R is 0.32 or R is 0.68 or negative 0.57 or whatever the case may be. What do those numbers mean? R is negative this. Okay. So the answer is it means nothing.
Just
And the answer is it means nothing. Okay. It's R squared that has meaning. And to explain that, let's focus on the following example. There's a lot of variability in course grades. How well can we predict a student's grade from the number of times that the student was absent? How well can we predict a student's grade from the number of times the student was absent? So what we have here is 9 students. The first 3 had no absences. These are their grades. 1 absence. These are their grades. 2 absences. This is their grade. 4 this, 7 that, and so on. And we plot them all. Does it seem reasonable that as the number of absences increases, as a general rule, the grade drops? Does that seem like a trend that makes sense? Yes, no, everyone, maybe so?
yes.
Okay. The question is, does that perfectly predict grades or not? In other words, if I tell you how many absences you have, can I predict precisely in advance what your grade is going to be?
Yes.
Really? Look at all those dots.
No.
Do any of those dots actually fall on the line? Maybe one of them does. But for the most part, look at the first 3 people. They all have the same number of absences, but they have different grades. Right? Yes? Come on, speak. Communicate. Yes?
Yes.
Yes.
So grades, so
Yes.
okay.
Yes.
So, thank you.
Yes.
Thank you. So absences alone is not a perfect predictor of grades.
It is in our class.
No, it's not in our class. If I look at people's grades and I see people with the same number of absences, they're not going to have the same grades. Right?
Yes, sir.
I mean, you see that, Miriam?
Yes.
So absences alone does not perfectly predict grades, but does it predict them reasonably well?
Yes.
How can you tell based upon that graph that it
Yeah,
predicts them
there's a
reasonably well?
trend
Certainly a trend.
because
Right.
it's a steady line.
Well, I mean, the line is
Going
the best
down.
fit line, but the dots seem pretty linear, correct? In fact, the R value is negative 0.8, which means it's, I mean, if R was negative 1, it would fall exactly on the line, right? So negative 0.8 seems pretty decent. But it's obviously not a perfect predictor because if you look at the absences, you have people with the same number of absences but at different scores. So there must be other things besides absences that we're not considering. What are some things besides absences that we're not considering here? What are some things besides
The
absences?
material. Well, the stuff that the difficulty of what you're learning or whatever. I don't know.
Well, yeah, but I'm saying everyone will be learning the same thing.
Cheaters. There's
Huh?
cheaters.
Okay, people can cheat.
They're not taking into fact, test grades. People can
sorry?
get different scores on their tests.
Right. So the question is, the question is, what besides absences can help predict what people are going to get on their test scores? Right. Absences alone is not enough because you see here that even knowing how many absences, we don't know exactly what their score is going to be. So what else are we missing besides absences? Practically, not mathematically, practically. Besides absences, what else goes into your test scores?
Assignments.
Okay. What do you mean by assignments?
Averages of the
No, guys,
assignment
don't
grades
think
or something?
mathematically. Just don't think mathematically. Think practically.
As,
Think
like
practically, huh?
whatever Patty said, assignments, the grade of the
No,
assignments.
no. These are just tests. I'm not talking about other grades. Just tests.
Oh, studying.
Yeah, how much you study.
The time they study.
Yeah, the time they spend studying. The prerequisite courses that they might have.
What they ate for
How smart
breakfast.
they are, huh?
What they ate for breakfast.
what they ate for breakfast, how much they slept the night before. You know, these are all
What's going on at home?
what's going on at
Yes,
home.
Patty.
There's many things that could be affecting their grades besides just their absences. But this particular problem only considered absences and ignored everything else. So the question is,
In my opinion, this
Yeah.
is not a good study.
I agree with you, Patty.
in your opinion, what?
This is not a good study.
This is not a good study at all. Why not? Because they left a lot of
Because
stuff
there's
out?
no, it's just not two good variables. There's
Yes.
You're on to
Say it in
something.
words. Come on, you're on the
Yes.
spot here. What is it?
I'm gonna let Lori answer.
Lori, you gonna
No.
answer?
No, I was telling her she's on a roll.
Oh, okay. Well, she's passing the buck to you and you're passing it back. What a friend. So here's the thing. Absences partially predicts grades, as you can see from the trends, but not completely, because there's lots of things that we didn't consider. The question is, how well did the absences predict the grades versus everything else that we did not consider? Here's the answer. Take your R value, which is negative 0.8, and square it. What do we get when we do negative 0.8 and we square it? What number do we get when we do that?
Negative 0.8,
And negative
Yeah,
0.8,
negative
take negative 0.8 and square negative 0.8, what do we get?
6.64.
0.64, which is 64%. 0.64 is 64%, right? So that means 64%. Well, let me rephrase that. The fact that the grades differs can be explained 64% from absences, 36% from everything else. What the math is telling us is that absences are 64% of the reason why grades are different. And the other 36% are all the other things that we mentioned, possibly even other things that we didn't mention. But everything not considered can explain 36% of the reason why the grades are different. But 64% of it, the R squared value, squaring R, 64% of the variation in Y is because of absences. That's what our math is telling us. Which means if I'm teaching and I had a study like this done, I would tell my students, I would say, listen, 64% of the reason why you're going to do poorly in this class is by missing lots of classes.
So get your butt to class.
So get your butts to class and possibly the rest of yourself as well. Okay? Bring the whole thing, the whole kit and caboodle. Okay? Come to class. Now, just because you're in class, we didn't even mention this, right? Just because you're in class doesn't mean you're paying attention. Right? You could be there physically because you want credit. Oh, look, I came to every class. I'm trying so hard this semester. You saw me in class every day. You know how many students I've seen in class that have been on their computers or that are on their cell phone or do this or do that? The motivation we did not know we needed. Well, it's too bad. The motivation should always be felt to be needed, but you're right. Okay, so this is what the R squared value tells us. Okay, now let's dive deeper into this.
Ooh, deeper?
Yes. So we're gonna do some calculations here because there's a few mistakes on this page. So hopefully someone can find them before I do. First, we've recopied the number of absences, 00011244712. Let's see if that's correct. 00011244712. Copied it correctly. We copied the course grade, 90, 97, 83, 90, 98, 85.
Oh. They added more grades.
No, they made mistakes.
Oh,
90, 98, 85 should be 90, 97, 83. So these here Not that it matters for us because we're going to use the other ones. But for your notes, these ones should be 97 and 83 technically. Just mistakes. And they're only mistakes because of what comes next. Because this is what we're going to be using. Okay. So the first thing we're going to calculate is the deviation from the mean. Check all these values. Y minus Y bar. Of course, I can only do Y minus Y bar if what?
You have the mean.
If you have the mean. So let's go ahead and calculate Y bar. Go ahead and do that, please. Calculate Y bar. I'm going to do it here. You do it there. How do I calculate Y bar?
Add them and average, divide by. Are we adding all the grades and dividing?
Yep. So 90 plus 97 plus 83 plus 55 plus 88 plus 75 plus 78 plus 58 plus
Oh, you're so
42.
fast.
Well, thank you. That's such a great compliment.
You're supposed
What
to
do-
say it's not your first rodeo.
Wow, I should have, yeah. Have you ever been to a rodeo, Lori?
Long time ago.
A long time ago. I have never been to a rodeo.
It's exploiting animals.
Yeah, but so are zoos, aren't they?
Oh, I don't go to zoos.
Pony rides and, you know, the Amish.
Sea World.
SeaWorld, Shamu. Are you a vegetarian, Lori?
No,
Oh, so you eat meat?
sometimes.
Yeah, me too. Because I like meat. But some
I
people
had
are-
steak last night.
Oh, steak is good once in a while.
Guys, I screwed up a
Yeah.
little bit. I screwed up a little bit.
744. 744 divided by 2, 4.
I didn't get 744, by the way. Do that again. I didn't get
Ah,
744.
shoot. All right. This is, I'm
Try again.
gotta get a calculator that works. Wait a minute. Where's my handy dandy? Goodness.
Come on, someone else should be doing it too, not just Lori.
And I keep getting
What's Y bar?
distracted. 83 plus 55
74.
plus
What do you get?
8 plus
74.
I can't hear. Louder, please.
74.
74.
58 plus 42 equals 666 divided by
Make sure you get that, please.
689. 74.
74. Okay.
Whew.
Now, we're going to compute Y minus Y bar. 90 minus 74 is what?
90 minus 74. I forgot my little common core ways of subtracting. 16.
16. 97 minus 74?
97 minus 74 is 13.
Okay.
23.
How much is 97 minus 74?
Isn't it 23? I'm
23.
so brain dead.
Yeah, 23. 83 minus 74?
This is good practice.
Everyone should be doing this.
9.
9. 55 minus 74?
Negative.
19.
Negative 19, right?
Yes, Lori said negative.
I
and
said negative.
19.
We're tag teaming. I'm getting more coffee. Just a second.
88 minus 74.
14.
75 minus 74.
1.
And 78 minus 74. Oh, we got to fill in ourselves.
4.
4.
4.
58 minus 74.
58 minus 74. Negative 16.
And 42 minus 74.
Negative 32.
Negative 32. So those are all these guys. Now we're going to square them all. So this is kind of walking through it step by step. 16 squared is 256. 23 squared, 529. 9 squared, negative 19 squared, 14 squared, 1 squared, 4 squared. They didn't do, so we should do it ourselves. What's 4
8.
squared?
16.
16. And then negative 16 squared is how much?
256.
And then negative 32 squared,
1024.
1024. And now what we're going to do is add them all up together. So let's take out our calculator and let's do the same thing that we did for the other one. Let's add these numbers all together. Ideally, everyone works in this. So 256 plus 529 plus 81 plus 361 plus 196 plus 1.
2720 divided by,
I got 2720.
No, we're not taking an average. Not taking an average.
oh,
It's 20.
2720.
2720. Just
I second Lori.
okay. 2720. No averages. 2720. So the sum of those guys is 2720. Now, this is a little tougher. What is the predicted value y hat? The predicted value comes from the best fit line. What is the best fit line? They were so nice and they gave it to us. So let's rewrite it. Let's write the best fit line right here.
Oh, how do you know that's what that is?
Because grades, which is the y-axis, that's your y value, equals 84.8 minus 3.6 times absences, and absences are your x value, correct? So we have y equals 84.8 minus 3.6 times x. Does that make sense?
Yep.
Yeah, I just got to remember that's what the best fit line is.
So I want you to go ahead and come up with the predicted values for all of these guys. Go ahead and do that, please. Plug in 0, what do you get?
Oh, 0.
No. Plug in 0 to the formula that I just gave you.
The 84.8 minus 3.60. Or you put the grade in minus 3.6.
The grade is your x value, correct?
Yeah.
So you put the grade in is, sorry, absences is your x value. So you put the absence in as your x. When you put the absences as your x, what comes out from the equation? What's your y value?
The course grade.
Which
The predicted value.
the predicted course grade. So for the first example, what do we get? What's our predicted grade?
Negative 84.
No. Read the equation correctly. 84.8 minus 3.6 times the number of absences. 84.8 minus 3.6 times 0 is how much?
0.
0.
No, you do the multiplication first. You don't do the subtraction first. 3.6 times 0 is how much?
0.
And then 84.8 minus that.
84.8.
Which is why when x is 0, we get a predicted grade of 84.8. Yes, no, maybe so?
Okay. Yep.
Okay. How about when x is equal to 1?
$81.2.
Which is why when x is 1, these two, the predicted grade is 81.2. How about when x is 2?
77.6.
Well, I'll just read it because there's mistakes here, but actually do the math. Don't just read off what they have here. I'm not saying it's not right, but don't just say that. Read it.
77.6 minus 3.6. $74.
Say again what you just did.
The 77.6 minus 3.6. No.
That's not what our equation is. Our equation is 84.8 minus,
Oh, because that's the best
3.6.
fit line thing.
That's the best fit line.
84.8.
Where's everyone else right now? How come
82.8.
80? That can't be right.
Wait, what's happening? You're doing the 80.
84.8 minus
8 minus-
3.6 times 2.
Oh, times 2. Sorry. 0.6 times 2, the number of absences. Sorry. I don't see that in that. The way that equation is written doesn't
Yeah.
look like that.
What do you mean?
That's why I get
It
confused.
says grades equals 84.8 minus 3.6 times absences, correct?
Oh, I didn't know how it said times absences. So I'm going to put a little parentheses around absences, number of
Okay.
absences.
And
Sorry.
grades is my Y value and absences is my X value, correct?
Yes. Okay. So
So where's everyone else in this all this time? Come on, people, work, speak up.
I
But-
got 77.6.
It is 77.6.
Oh, okay.
aren't you doing the order of operations 3.6 times 2 and then subtract that from 84.8?
100%.
Okay. Woo, I caught up. All right. I'm
Okay.
back.
Now, next, what's the predicted value for absences equal to 4?
Oh, you're getting fancy.
70.4.
70.4, which they wrote in the next line. So this number here is wrong, and this one should be here, 70.4.
I want my money back for this textbook.
Okay.
Oh, wait a minute. It
you
was
got it.
free.
Okay. Now, how about for 7 absences?
59.6.
Which is their number that they wrote for 12, so that one's also wrong. And what should it be for 12?
41.6.
41.6. So what we're going to do now is calculate the residual. The residuals are the actual value minus the predicted value. So
Wait
what's
a minute.
90 minus 84.8?
90 minus 84.8.
I asked you first.
84.8.
90
5.2.
minus
5.2.
84.
Go.
97 minus 84.8?
Well, I bet it's 12.2.
Well, remember, there are mistakes.
97.
There are mistakes, so while it might
What
be
did you say?
Oh, that's right. I'm getting my money back.
97?
97
Well,
was my actual grade
Professor-
minus, huh?
12.2 is correct.
12.2 is correct. Okay. Next, actual grade 83 minus 84.8.
83 minus 84.8.
Negative 1.8.
That's it.
Is that what they have
That's what
there?
I got.
That's what I have. That's
Yes,
what they
that's what I
have. That's what everybody has.
Wonderful. Go through all of them and see if they're all correct. And if not correct, which is certainly a possibility, then correct them. Go ahead and do that.
Okay, negative. It's perfect. 88.
Everyone, please, not just the 4 or 5 who are actually vocally part of it.
75 minus 77.6 equals 2.6. 78 minus 70.4 equals 7.6. 8 minus 59.6 equals
Wait, do we do 59.6 subtract or did we do 41.6?
41.6.
For the last one or for this one?
Yeah,
These numbers
both of
here are
them.
wrong. We corrected it. These numbers here are wrong.
Okay.
They're all correct.
Well, there's one missing though.
Yes.
Well, I did that one.
What should it be?
7.6.
7.6.
Yes.
And now what I want you to
we
do
agree
is
with
I want you
Lori.
to square all these numbers.
Oh man.
Take all these numbers and square them. Let's check to see if those are correct.
Well, oh, the first one,
27.
27.04, but
That's right. I think it should be
27.04.
0.2 squared. 148.8. Yeah, they're doing the first number, Lori. So yeah,
Oh, just round it up.
you can't round. Yeah, if you round it up, it's still gonna be
Okay.
0.
Thank you.
Negative
So what do we get? Come
1.8
on.
squared.
0.8 is wrong.
0.8 is wrong. Yeah, it's supposed to be negative 3.2.
Not a 0.8. It's this one. My cursor was on top of it. This is 6.8. Is that wrong? Negative 2.6?
6.8. It's
No.
not supposed to be 38.6. Squared is 46.24.
36.3.
Or
Wait. Which one's wrong?
6.8.
yeah,
Oh, they rounded it. They rounded it.
No, it's not. It's not rounded.
Hold on.
6.8 squared, I mean, on my calculator says 46.2.
Yeah.
Why are you squaring 6.8? Wait. Why are you squaring 6.8? These are the residuals.
Yeah.
When you square them, you get these numbers.
Yeah.
So why you, oh, this one here, you mean?
Yes.
Oh, 6.8 squared of minus 46.24.
Yes.
Wow, that's way off. And then 5.2 squared is 27.04. 12.2 squared is 148.84. 1.8 squared is 3.24.
I got a negative.
The score, no, negatives go away because you're squaring them. 2.6 squared is 6.76.
7.6
squared
times
is,
7.6, 58.
sorry?
7.7, I mean 5.8, no, 7.6
2.56.
equals 57.76.
This is 0.16.
6. Why did they put 2? Is it because they rounded up?
Yeah, they were rounding some of them, but some of them were just mistakes. 27.04 plus 148.84 plus 3.24 plus 686.44 plus 46.24 plus 6.76 plus 57.76 plus 2.56 plus 0.16. This gives me 979.01.
What's the last number in that column?
It's 0.16, Lori.
0.16.
Oh, thank you.
0.16.
No problem.
Okay, so we have these two numbers. Okay, we have these two numbers.
Is that
This is called
97.9?
979.01.
Oh.
979.01. So here we have 2723. This is the TSS. And here we have 979.01. This is the SSR. Okay, the TSS stands for the total sum of squares. The total sum of squares. And the SSR stands for? Can anyone guess?
The
The sum of the
squared residual.
residuals. Excellent. The SSR is the sum of the squared residuals, and the TSS is the total sum of squares. Now, write those numbers down because as we go to the next slide, those numbers are going to be important. Okay, the total sum of squares and the sum of the squared residuals. Okay, TSS, the total sum of squares, and the SSR is the sum of the squared residuals. Now calculate SSR over TSS. What was it? What was the TSS again? I forgot.
2720.
Okay, so 979.01 over 2720, we get a value of 0.36 approximately. We get approximately 0.36.
This, oh,
The
That
SSR of
over
the
that.
TSS is approximately 0.36. What do you think that means, 0.36? Well, let's think about that. Does that number in any way, is that familiar in any way for this problem, 0.36?
does that have something to do with how many away from the average? No.
No, let's not worry about that.
Is it familiar?
Is it familiar?
I mean, we multiplied 3.6, but I don't know if that has anything to do with this.
What was our R squared value again?
0.8,
No, that was our R value was negative 0.8. What was our R squared
Oh.
value?
0.64 or 64%,
And what is this number?
36%.
64%, 36%.
About half-ish.
Huh?
Never mind.
They add to 100%.
36 plus the
36% plus 64%. They add to 100%.
6 plus 64%. Where was the 64%? I'm sorry.
That was our R squared value,
Oh,
right? That was our R squared value.
how many slides back was that?
It was on our best fit line. It said R is negative 0.8.
Oh,
If you go back to here,
yeah.
R is negative 0.8. So the 0.36 represents the proportion of the variability that is not included in the best fit line. Whereas the 0.64 is the proportion of variability that is included in the best fit line. So what is the proportion of variability that the regression line does account for? The answer to that, 64%. The regression line accounts for 64% of the variability. That is the R squared value. The R squared value is 64% of the variability. The SSR of the TSS, that's the remaining 36. Does that make sense?
Yeah.
Okay.
Sorta.
Well, listen, you start off with sorta, then you go over it. It sort of becomes kinda. Then you go over it again, and kind of becomes,
And then it's
over it again. And it's like, oh, I think maybe I understand what he's talking about now. So here are all the grades. Here are all the grades. When we look at all the grades, we see they're all over the place. They're scattered from 40 to 100. Grades are all over the place. Lots of variability. Correct? Yes, no, maybe so?
Yeah.
Okay. But when you look at the residuals, if you actually look at the residuals are actually pretty small in comparison, right? The actual grades are 40 to 90 something, but the residuals are much smaller and tightly packed. The SSR is much smaller than the TSS because for the SSR, the numbers are much closer together. Okay, so the SSR over the TSS represents the proportion of the variability in the Y values that remains after fitting the least squares regression line. That's the one that we can't explain. R squared, which is 1 minus that, is the proportion of the variability in the Y's that is explained by the regression line. Does that make sense? Yes, no, maybe so? Kind of? A little
Kind of.
bit?
Yes, it does.
Represents the proportion of the variability.
Kind of.
As it remains and the residuals after.
Now, if all of the points had fallen on the line, then what would the value of R be in that case? Well, it had negative correlation, so it would be -1 with an R squared value of +1. That means all the values are perfectly on the line, and my dot plot of the residuals would look like this. They'd all be 0. I would have no residuals because every point is exactly what's predicted by the line. Nothing was off the line at all. So every single residual is 0, and it's all centered on 0. Okay. And the value of the RSS in that case, because there's no residuals, that will be 0 because there's none left. And what would the TSS? Would TSS be the same? No. TSS is the total sum of squares. The grades are all over the place. Even if they all fit on the line perfectly, even if they were all perfectly on the line, even in that case, the TSS would not be 0 because all my Y values are different. But the sum of the squared residuals will be 0. Does that make sense? Yes, no, maybe so. Are people with me? I don't know what's going on. People got to talk.
Yes, Professor, we're with you.
It's just,
Okay.
Yeah, we're with you.
just a lot of new information for me.
I know.
Can
I'm
Um,
not whining about it. I'm just telling you.
And
Can
we're
you
not,
just explain why it's no? Sorry.
because TSS takes into account that all the Y values are different. They're all different Y values. So the average of the Y's is not going to be the same number as all of them because all the Y's are all over the place. But the residuals are all 0. So the average of the Y's is different than the Y values, but the average of the residuals is all 0 because they're all 0. Because they're all on the line itself. No, nothing about focus. The TSS deals with the actual values. Where are the actual Y values? The actual Y values are here, 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 and so on. So the TSS accounts for all the different Y values. The RSS is only about how far they fell off the line. It doesn't care what the actual Y values are. It cares where they are in relation to the line. So if they fall all on the line, the residuals are all 0, even though the Y values are all different.
Can you explain why you got the value of R or how you got it?
Well, R came from a formula. R was,
No, like when it's in the group activity. Is that what it's from?
group activity. Here?
No. Where it says now suppose all of the points in the scatter plot are following exactly.
Oh yeah, if they all fall on the line, the correlation is either 1 or -1. If everything falls on the line, it's perfect. R is 1 and -1. 1 if it's positive, -1 if it's negative. That's perfect correlation. Everything is perfectly correlated and everything works out perfectly.
Oh, okay.
That's
Okay,
just a
thank you.
fact. That's just a fact.
Professor,
Yeah.
so if we are given the value of the regression line, it'll be easier to find the value of R squared?
Only if you give an R.
Only
They gave me the line and they gave me R. If they only give you the line, that's not easy to find R. I got to go all the way back to this. If I want to find R from the data points, that's how I find it.
Okay, and so if you're given R but not the regression line, could you just subtract R from 100 and get the regression line?
No, they're two different things.
Oh, okay.
They're two different things. It doesn't work that way.
All right, thank you.
All right, well, we didn't finish the chapter. We're gonna continue this next time. Hopefully finish it on Wednesday.
Thursday.
Thursday, I'm sorry. We did not finish it. It's a tougher chapter.
It
And,
is.
It is. And we'll finish it on Thursday. And again, the goal is not to understand everything. The goal is to understand what we cover as good as possible. So
Yeah.
if we don't cover something, so be it.